a biconvex converging lens. Now look at what happens when I place it in the path of these rays. See that? The rays hit the lens and then they get converged to a point. And hence the name converging lens. The other type of lens is a diverging lens. And over here, I have a biconcave diverging lens. When the rays pass through the lens, they get diverged. If you look closely, you'll notice that they look like they are emerging from a point behind the lens. Biconvex converging lens, which we call the eye lens, and a screen, which we call the retina. So let's try to simulate the human eye over here. So let's say that this biconvex converging lens plays the role of our eye lens. Okay, and I have a screen over here that's going to play the role of our retina. So if you look closely, this is what happens in the case of a healthy eye. The rays come off objects, and then the eye lens converges those rays to a point on the retina. And therefore, this person sees a clear image. And defect is called nearsightedness or myopia. In this case, the person can see objects that are close by clearly, but far away objects appear blurry to them. When this person looks at objects that are far off, those rays get converged to a point in front of the retina, like this. And therefore, he ends up seeing a blurry image. But this can happen if rays are getting converged a little too much. So you need to negate that. One way to do that is to introduce a diverging lens. Watch. Here, the moment I place the biconcave lens, the rays now intersect, they appear blurry, and objects that are far off appear clear. Now, when you look at their eye, this is what happens. So when these people look at objects that are close by, those rays get converged to a point behind the retina, and therefore this person ends up seeing a blurry image. Again, this can happen maybe because the eyeball itself is too small. So over here, I have a biconvex converging lens. Look at what happens. You see that? The moment I bring the lens, the rays now intersect